Confused? A lot of information thrown at you. Hopefully, as we put it all together, it will start to click and everything will fall into place. First of all, though, we talked about the relative reactivity and whether a substituent can make the benzene more reactive because it's putting electrons into the ring, or less reactive because it's effectively taking electrons out of the ring. Well, now I said that the second thing we had to consider was the Regio Selectivity, if there is any, the position of the substitution. So here is a substituted benzene. I just got that X group on, whatever the substituent is, react it with an electrophile, and we know the electrophile is going to substitute for one of those hydrogens. The question is, which one? So this is how one shows generally, yes, there's an electrophile bonded somewhere to the ring, but that electrophile can be at a carbon 2, carbon 3, or carbon 4, or to use my old-fashioned terminology, ortho, meta, or para. Well, there are therefore three possibilities. We can have substitution at the 2 position, the ortho, the 3 position, the meta, or the 4 position, the para position. Okay. Now, whichever one of those occurs, we need to, of course, think about the intermediates. So this next slide is going to have a lot of aromatic rings on it, a lot of green arrows, as we consider the intermediates that would take place. And this is, of course, the resonance stabilized intermediates for either ortho attack, meta attack, or para attack. And I'm going to give you a little spoiler here. As you will see, the intermediates are the same for ortho or para attack. So therefore 2 and 4 substitution, ortho and para substitution, usually occur together, and that will become very important in a little while. So, ready for it? Ortho, there we are. There's the ortho hydrogen. So we're going to think about, here is our substituted, the X. The electrophile is going to come in. What happens if it attacks at the ortho position? So in other words, electrons from this double bond are going to come towards the electrophile, and when they do that, of course, you break this double bond because you've made the bond to the electrophile. We're saying we're making the bond to the electrophile at the ortho position, which puts a positive charge there at carbon 3. Okay, now of course we can stabilize that because we can move these pi electrons from this bond to that bond. And now we've got the positive charge on the carbon 5, if you like. That's carbon 1, 2, 3, 4, 5. And then again, we can stabilize that by taking these 2 electrons here and shunting them around to give us that resonance intermediate. Okay, so with benzene, there were 3 possible resonance intermediates. With ortho attack, there are 3 possible resonance intermediates, or so it would seem. Okay, but do notice where those particular positives now are. Okay, now meta though, let's do this first. There's the meta attack, and now I'm going to use that same double bond, but instead of it bonding with the electrophile at the ortho position, now I'm going to bond it at the meta position. Okay, so meta attack coming in, there's the positive there on carbon 2. We can move electrons over from this double bond to that double bond, so now the positive is no longer on carbon 2, it's on carbon 6. Or I can move electrons from this double bond up to there, so now that positive moves from carbon 6 to carbon 4. So meta attack puts the positive charge on carbons 2, 4, 6 relative to the substituent. Ortho puts the positive charge on carbons 3, carbons 5, and carbon 1. Finally, para. Yes, para. There's the electrophile coming in. A couple of electrons move over, leaving us with the electrophile attached to the para position, carbon 4. And we got positive charge here on carbon 3, which of course I can move by moving these double bond, or the electrons in this double bond over. So now we have the positive charge on carbon 1, and of course I can move the 2 electrons from this bond here to that bond there, moving the positive charge back to carbon 5. So again, notice here, ortho and para, the positive charge is stabilized on carbons 1, 3, and 5. And for the meta, it's stabilized on carbons 2, 4, and 6. Okay, now Lots of benzene rings, as I promised, lots of green arrows, but I'm going to focus in the next slide on just 2 of these possible intermediates. Both ones that come out when you have the orthopara or the 2,4 substitution, and they're the ones in which one of the resonance structures has the positive charge on carbon 1. Right? In other words, the positive charge on the carbon that has the substituent on it. And because, of course, we've been thinking about that substituent in terms of what happens if it's positive inductive, positive mesomeric, negative mesomeric, you can see where we're going with this, I hope.